You clicked on this video because you want to master organic chemistry, one of the hardest courses you will ever take in college. I came into Orgo with no prior knowledge or experience, and I had to learn the hard way how to effectively and efficiently study for this course. This video will go over how organic chemistry is generally structured, the type of exam problems you can expect to see, and how I mastered the material with no prior knowledge. Hi, I'm Michael, I'm a student at Brown University, and Orgo is generally divided into 2 semesters. Orgo 1 and Orgo 2. Orgo 1 teaches the basics, while Orgo 2 expands upon the knowledge learned in Orgo 1. More specifically, Orgo 1 material brings an introduction to the basics, which includes naming molecules, drawing Lewis structures, orbitals and hybridization, Newman projections, stereoisomerism or RS and EZ, and a basic introduction to acid and base. RS and EZ are used to help determine the certain rotation of molecules when they are allowed to be rotated around some bond. Further along in Orgo 1, you learned about reactions with alkenes or hydrocarbons with a double bond, and reactions with alkynes, or hydrocarbons with a triple bond. Then you'll learn about substitution and elimination reactions. Substitution reactions being when something is replaced with something else, and elimination reactions being when something is eliminated from a molecule. Then you'll learn about alcohols, leaving groups, and protecting groups. Leaving groups are basically parts of a molecule that leave in a reaction, and a protecting group protects a molecule or blocks it from a certain reaction. Finally, you'll learn about epoxides, which are simply 3-membered rings with an oxygen as one of the members of that ring. Orgo 2 material is summarized much more succinctly, but the topics go more in depth. So the first thing that we learned in Orgo 2 was spectroscopy and NMR, or nuclear magnetic resonance, which is simply used to help identify certain molecules. So from the use of infrared spectroscopy, mass spectroscopy, carbon NMR, and hydrogen NMR or HNMR, we were asked to identify certain molecules, or using some certain aspects of each NMR spectroscopy, we were asked to identify certain components of a molecule. It's basically putting together clues to figure out how to draw a certain molecule that is being examined under this spectroscopy and NMR technique. Then you'll learn about organometallic reagents, which are generally molecules that have a lithium or magnesium bonded to them in some fashion. Then we learned about reactions with aldehyde and ketones. Aldehydes being a carbon bonded to an oxygen with a double bond, and that carbon also being bonded to an H or hydrogen, and ketones being a carbon double bonded to an oxygen, but that carbon not having any bonds to an H or a hydrogen. Then we learned about the reactions of carboxylic acids and carboxylic acid derivatives, or CADs. Finally, we learned about the reactions of enolate anions and enamines. Enamines are simply molecules that are formed by the reaction of some sort of aldehyde or ketone with a secondary amine. And a secondary amine is just a molecule that has a nitrogen bonded to 2 carbons. Enolate anions are simply derived from the depronation of some sort of carbon atom double bonded to an oxygen atom. So then there's some sort of minus charge somewhere within the molecule. Orgo 1 simply introduces you to various topics that are used in Orgo in an introductory fashion. And in Orgo 1, you'll often be asked to use a molecular modeling kit. So it looks something like this, which is the one I had to use. I used Dalton Labs, and in the kit, it looks something like this with different molecules that you can move and bend around and see the actual formation of. So this is a simple 6-membered carbon ring without the hydrogens. And you can just simply rotate this around and see how a molecule actually is supposed to look based on chemical theory. So a 6-membered carbon ring that looks like this can actually usually fold in some manner like this. So it's kind of difficult to see from 2D, but it can fold in various ways, and it's constantly rotating about the certain bonds that are formed. So that's what the modeling kit is to help visualize, and it's very much emphasized in Orgo 1, but not as much in Orgo 2. After the introductory material, Orgo 1 also teaches basic reactions, and I like to see reactions in 2 components. So the reaction includes the reactant, the things that you add to the reactant, and the product. And then in addition to the reaction is the mechanism, or the specific steps that determine how those things that were added get that reactant to that product. That tends to be the more complex part of each reaction. Simply trying to memorize or know each of the simple reactions isn't that much knowledge to retain, but having to know all the mechanisms is somewhat difficult, and it comes with a lot of practice. And Orgo 2 simply teaches you spectroscopy and NMR, and goes further into different types of reactions with different types of compounds and molecules. So in a general sense, it's not that much to comprehend, but knowing that general idea would have really helped me when I went into this class. Now, looking at potential exam problems in Orgo. In Orgo 1, potential exam problems are very easy to predict with the introductory material. There are different ways to represent molecules when we draw them. So for example, when we learned about Newton projections, which is a head-on view of the molecule, then on an exam, it would be likely that you would be asked to simply draw a different representation of that molecule based on one of the different visualizations that are learned in Orgo 1. Depending on the course, you may be asked to name a certain material that is drawn on a piece of paper, or you may be asked to draw a certain material based on the name given. You may also be asked to label the hybridization of a molecule, which is based on how orbitals mix within a molecule. In reference to spectroscopy and nuclear magnetic resonance, or NMR, in Orgo 2, those problems are pretty straightforward. It just comes with practice, because what we would often have is all 4 of the spectroscopies and NMRs are given for a certain molecule, and using all of those, we had to determine what exactly the molecule was meant to be. That wasn't very difficult because it wasn't connected to all of the material. It was just something that you had to practice. In general, most of the problems in Orgo will include one of the 4 following problems. Firstly is the mechanism problem, which examines a reactant and a product, and sometimes gives the reagents that were given to make that, and then asks you to draw the specific steps that led to the formation of that product. In order to solve these problems, I was taught by teaching assistants to simply make a chart of the bonds broken and the bonds formed from the reactant to the product, and then to use that chart to figure out a reasonable path that would go from that reactant to that product. This was my biggest weakness when doing Orgo, and I felt much more comfortable with it very late in the courses. But what I really came to understand is that if I am not sure how a step came about when I'm trying to draw a mechanism, I have to understand why I believe that that step was not feasible, and then try to understand why it actually is feasible and why I didn't think of that step before. Also, a lot of the mechanism problems tend to mimic the mechanisms of basic reactions that are taught in class. If they are more difficult, then they're not going to very much mimic them, but those are often the baseline from which these mechanisms are going. The second type of problem is the box problem, which simply gives the reactant, the product, and the components needed to form that product from that reactant, and then puts a box around one of those things and acts like it's missing. So, for example, the reactant might be missing, the product might be missing, or the reagents that are needed to form the product might be missing. And then you have to determine what those specific molecules were. This is more of a simple problem because it generally asks you to simply know what was taught in class in terms of the simple reactions and the products that are formed. The third type of problem is a product prediction problem, which gives a starting molecule and then multiple arrows representing different reagents or reactions that are done to that molecule. And then what you're asked to do is to draw the product that forms as a result of all of these reactions on that initial reactant. These can be difficult because of different spatial orientation that results from different reactions, and then trying to figure out how all of these reactions come together from a simple reactant, because one mistake that is put on the reactant can then affect the entire pathway that one chooses to do. One just simply needs to be very careful and understand what reagents do to a molecule. The second most difficult type, in my opinion, after mechanism problems are synthesis problems, which gives a reactant and a product and then asks how to get to that product from the reactant using different sets of reagents. So it's not one step like the reactant to product reactions taught in class. It makes use of all of the reactions that are taught in order to go from one specific reactant to one specific product. So usually it involves at least 3 steps to make it more of a difficult or challenging problem, and it can go as high as 6 steps depending on how complex of a pathway you determine the product to come from. If you've made it this far in the video, be sure to leave a comment asking any question that you have about Orgo. So now that I've gone over all of the general stuff, here's my advice for organic chemistry. First, organize notes efficiently. At Brown, when I took organic chemistry, each exam would allow us one cheat sheet of material that we could look at and reference during the exams. So I really didn't have to memorize much, but I did have to know how to apply the material that I learned. It was recommended to write these out, but since I was trying to squeeze as much material possible onto those pages, I would use a Google Doc and paste all the reactions in a very organized way that I would use for the exam. Sometimes I would print my cheat sheet very close to the start of the exam, and I would realize that I can't even see some of the notes that I wrote, and I have to go back and expand it. The method has its flaws, but I used that throughout my entire time at organic chemistry, and I found it to be fine. Other people who also did well in organic chemistry tend to write out the reactions, but the Google Docs are what works for me. Also on the cheat sheet, if you are given one, I find it important to write down any mistakes that are common that I make when studying for the exam. For example, if I forget to add some sort of reagent, or I always forget to mention or add this one thing, then I tend to write that down so I can reference it during the exam, and I know that I won't make that mistake when I'm in a rushed feeling during that test. Also, organizing these cheat sheets or organizing notes in general to study can take a very long time because it takes a while to wrap one's head around it, and I have no idea where the important reactions are, what all the important notes I have to take into consideration are. So what I did was I took advantage of the tutoring offered at Brown, and then I would often reference those notes because they very succinctly summarize the important notes of organic chemistry. And I would also ask for older friends for their notes to see how they summarize these reactions, and this would very much help me study and prepare for these exams. I also mentioned in one of my previous videos that I literally spent 10 hours studying for organic chemistry one week because I wanted to dedicate myself to studying earlier than a few days before the exam, but those 10 hours were literally spent trying to summarize notes that I could have just taken from tutoring notes or an older friend's notes. So it's very important to organize notes efficiently and spend more time doing practice problems. My second piece of advice is to study efficiently and consistently. At Brown, we are offered 3 major resources to study for organic chemistry exams. Firstly, were textbook problems. Secondly, were undergraduate teaching assistant packets or UTA packets made every week by the TAs. And finally, were homeworks given before each exam that were made by the professor and meant to mimic the problems that we would see on the exam. I usually tended to study later than I should have, but what I learned to be the most efficient method for me after organizing my notes was to do the teaching assistant packets and then approach textbook problems if I'm very much struggling to complete a teaching assistant problem. Ideally, this would be done every week as the packets come out, for example, and studying would be more consistent, but we all procrastinate, so I would just try to get them done as efficiently as possible. And then before each exam, a homework would be given, and at that point, students should have a general knowledge of the types of problems and should have a greater knowledge of how to approach more complex problems from the TA packets. So that's what that homework was meant to be for. And when I say study efficiently, the major point I'm trying to bring across is that doing problems is much more effective than simply reviewing or organizing notes. If you don't have the luxury of having a cheat sheet for exams, then what I would do is to make flashcards after every lecture. I like to use Anki, but other people use Quizlet or physical flashcards. And then I would go after each lecture and make the flashcards and review them every single day. Otherwise, it can be quickly overwhelming, and there's no way to last minute cram all of that information as well as apply that knowledge in practice problems. In addition, especially in Orgo 1, understanding is more important than simply memorizing what's going on with the reactions. And in general, organic chemistry exams will have knowledge be applied versus simply regurgitating information. But organic chemistry tests weren't like biology tests in a sense where they could ask for the definition of something, or in a sense where they would ask some sort of multiple choice question. They could, but in general, organic chemistry tests were more like math problems where you had to somehow figure out how this came about, and it was more applying knowledge rather than just simply rote memorization, which is why we had cheat sheets in the first place. Third, study alone and then seek help for any questions you have. At Brown, we would be offered weekly review sessions with teaching assistants or TAs, but those sessions were in big auditoriums, which were very loud usually, and not a very good place to learn organic chemistry or study organic chemistry. The only time that I actually saw progress when going to those sessions were when I came with questions after doing things by myself. The reason studying by myself is so important is because if I try to do a TA packet, for example, or a textbook problem with my friend, yes, I can ask friends for help, but then it would often be the case that the friend, for example, would either be behind on that topic or ahead on that topic. And then I would believe that I know that topic when in reality I might have been propelled by the knowledge of a friend. So I always encourage reaching out to friends when I have a question or reaching out to TAs when I have a question, but studying should be done alone because that's when the real knowledge and mastery comes about, because I can understand material on my own. It takes so much courage to go up and ask teaching assistants about my weaknesses in organic chemistry, but the courage is definitely worth it because I was asking a teaching assistant about a mechanism problem that I didn't understand at the end of Orgo 2, and he guided me through it in a way where I completely understood what I was doing, and once I finished the problem, I felt much more confident about doing mechanism problems on my own. It felt so much better to have the clarity behind mechanism problems, and I would have never got that if I never had the courage to ask the TA to explain a certain mechanism problem to me from a previous exam. So organic chemistry is not meant to be learned alone. Resources will always be available to you, so it is so important to take advantage of them, because that is when a lot of the complicated questions that one has may be answered very effectively and efficiently. Specifically, undergraduate teaching assistants or TAs have knowledge that is closer to your level of understanding than a professor. A professor is at least a decade removed from the knowledge that you'll be learning in most cases, and usually at least a couple or more decades removed from the information that they are teaching from the seat that you are sitting in. So asking a teaching assistant who either just took the course or took the course within a couple of years of when you were taking it will provide great advice not only as to how to approach organic chemistry, but about the specifics of the class that you are taking at whatever institution you are taking the course at. And with that, I was able to master organic chemistry. If you want more studying advice, be sure to check out my video on my top tips for studying effectively. Thanks for watching. Be sure to like, subscribe, and hit the bell for more college advice, and I'll see you next time.